you very much, Deborah. It's a great pleasure to come here, and thank you for organizing such a wonderful conference. So I'm going to talk about the relationship between causal inference and statistical inference in general. So I'm not speaking to the debate between frequentists and Bayesians in this talk, but just the connection between causation and statistics. I'm going to be talking about causal inquiry, and I'm going to be understanding causal inquiry as establishing, the act of establishing that A is a cause of B, or assessing whether A is a cause of B. Now, key techniques for causal inquiry are usually couched as statistical techniques. For example, analysis of RCTs, analysis of observational studies, meta-analyses, learning structural equation models, learning graphical causal models, and so on. So the question arises, what is the connection between causation and statistics? And there are two natural theses one might put forward here. One is a weak thesis that statistical techniques are useful for causal inquiry, but they're not the whole story. Alternatively, one might put forward a strong thesis, namely that causal inquiry is a purely statistical problem. I think that there has been a trend from the weak thesis to the strong thesis over the years in scientific research. And I'm going to explain why I think that and why I think that's a problem. So first of all, I just want to note that two champions of RCTs, namely Fisher and Bradford Hill, they can both be interpreted as advocates of the weak thesis. So the idea that statistical techniques are useful for causal inquiry, but not the whole story. So Fisher, for example, says, from the modern point of view, the study of the causes of variation of any variable phenomenon, from the yield of wheat to the intellect of man, should be begun by the examination and measurement of the variation which presents itself. And he was a great champion of both randomized and observational studies to look at partial covariations as a preliminary to causal analysis. But he never advocated, as far as I know, the strong thesis that causal inference is just reducible to statistical inference. Bradford Hill can be viewed as another advocate of the weak thesis. So he says, over a fairly wide expanse of clinical medicine in Great Britain, the statistical approach has been accepted as useful. The statistically guided therapeutic trial is not the only means of investigation and experiment, nor is it invariably the best way of advancing knowledge of therapeutics. I commend it to you as one way, and I believe a useful way. And Hill was keen to stress the gap between statistics and causation, between association and causation. And he famously put forward 9 viewpoints or indicators of causation to help us when we come to establish causal claims. And several of these indicators are not statistical indicators. Many of them are answerable with the benefit of statistical techniques, but some of them aren't. I think these days, however, the strong thesis predominates. So this is the thesis that causal inference is at root statistical inference. Why is this the case? Well, evidence-based medicine and evidence-based policy, these focus almost exclusively on the analysis of RCTs in practice, and this is usually a statistical analysis. Quantitative statistical methods now dominate causal inquiry in the social sciences. So while there are qualitative methods, of course, they're not normally put to use for causal inquiry. Graphical causal modeling approaches, these conceive of causal relationships in terms of statistical models. So you can learn causal relationships from observational and experimental data. And I think one way the strong thesis is motivated is on the grounds that recent improvements in statistical methods warrant the strong thesis. So for example, Pearl says, when attempting to make sense of data, statisticians are invariably motivated by causal questions. The peculiar nature of these questions is that they cannot be answered or even articulated in the traditional language of statistics. Only recently has science acquired a mathematical language we can use to express such questions, with accompanying tools to allow us to answer them from data. The development of these tools has spawned a revolution in the way causality is treated in statistics and many of its satellite disciplines. So the strong thesis is advocated on the grounds that statistical techniques, statistical methods have progressed. There's also a trend towards conflating causation with some kind of correlation conditional on confounders, so maybe a counterfactual correlation. So for example, RCTs are touted as providing unbiased estimates of causal effects, average treatment effects. Here, causal effects are just understood as what is learnt from RCTs, so a certain kind of probabilistic dependence. So I think that these two reasons why the strong thesis is now dominant in scientific method. I'm going to suggest that the replication crisis actually results from this move from the weak to the strong thesis. So I think it's an artifact of this trend over time. And I'm going to suggest that a particular theory of causal inquiry that's compatible with the weak thesis, evidential pluralism, can help to mitigate the crisis. So I'm going to introduce evidential pluralism. I'm going to explain briefly how it's been applied in medicine. Then I'm going to talk about the replication crisis in general terms, and then I'll try and give one or two examples of how I think evidential pluralism can help redress the replication crisis. So first of all, evidential pluralism. What is it? It stems from the idea that correlation isn't causation. So a correlation between two variables A and B might be due to one of a large number of possible explanations, one of which, of course, is causation. A is a cause of B. But there are many others. So reverse causation, various kinds of bias, including confounding, of course, sheer coincidence, so sample size, fishing for correlations, and then non-causal connections between the variables in question. So the variables may overlap. There may be temporal trends, semantic relationships, constitutive, mereological, logical, nomological, or mathematical relationships between the variables in question. Any of these possible explanations can give rise to a correlation. So a causation is just one out of many potential explanations of a correlation.
Excuse me, John, can you make your slides bigger?
I'll try. Can you still see the slides?
Yes. Just some people were mentioning, yeah, much better.
Is that better?
Yes.
Yeah. Okay.
Thank you.
So what picks out a causal account of a correlation in comparison to one of these other accounts? Well, if A is a cause of B, there's going to be some complex of mechanisms that explain instances of B by invoking instances of A, and that can account for the magnitude of the observed correlation. So the thought is, in order to establish causation, you need to establish both the existence of an appropriate correlation and the existence of an appropriate mechanism that can explain that correlation. And this motivates evidential pluralism, which is a theory of causal inquiry. So at the top of this picture here, we see that in order to establish A is a cause of B, we need to establish A is correlated with B, and there's some mechanism linking A to B. Now, the obvious way to establish a correlation is perform some kind of association study that measures A and B together. Observational experimental studies, these measure the extent of the correlation along this channel alpha 1. Randomized controlled trials are particularly prized because they provide indirect evidence that the association, the observed association, may be due to a causal connection. So they provide indirect evidence that there's a mechanism linking A to B, and they do this by reducing the probability of confounding. But there are other ways, of course, to establish the presence of a linking mechanism between A and B. And this can be done by positing hypotheses about the particular mechanism of action and any interacting mechanisms. And we can find out about these hypotheses by conducting mechanistic studies, which are studies that try to find evidence of features of the hypothesized mechanisms. And these mechanism hypotheses can be qualitative hypotheses, or they may take the form of structural equation models or graphical causal models. The point is that what we're trying to do at this stage is to say something about the mechanism linking A to B. An evidential pluralism can be thought of pluralism about the objects of evidence, so correlation and mechanism, and pluralism about the kinds of study you need to look at to assess causation, association studies and mechanistic studies. And these studies reinforce one another. So association studies on their own can be unreliable because of biases and so on. Mechanistic studies help to isolate the correlations that are genuinely causal. Mechanistic studies on their own can suffer from problems. Mechanisms can be very complex, and it can be hard to see whether A makes a net difference to B over a complex mechanism. And association studies are needed to help isolate those mechanisms that do make a net difference. So the thought is that association studies and mechanistic studies reinforce one another. There's an analogy here with reinforced concrete. So concrete on its own is resistant to compression, but fails under torsion. Steel is strong under torsion, but buckles under compression. Put them together, though, and they make up for one another's deficiencies, and we can build very strong structures. Okay, so that's a quick introduction to evidential pluralism. So let's look at how it's been applied in medicine. First, what's the status quo? Well, that's evidence-based medicine. From the perspective of evidential pluralism, this focuses on the left-hand side of the picture I showed earlier, the alpha channels, and takes mechanistic studies to be strictly inferior to association studies. So here we have the standard evidence hierarchy with RCTs near the top, observational studies, ideas and opinions, and then below that, animal research, in vitro research, the kind of research that can give rise to high quality evidence and mechanisms. And Goyat et al. Emphasized that evidence-based medicine de-emphasizes intuition, clinical experience, and pathophysiologic rationale as grounds for clinical decision-making. So they want to put mechanistic evidence at the bottom of the hierarchy. Evidential pluralism, in contrast, takes mechanistic evidence seriously alongside the standard studies, observational and experimental studies. And this leads to an approach in medicine called EBM+. EBM+, the idea here is to systematically scrutinize mechanistic studies alongside association studies. So don't just ignore them, try to systematically assess them in the way that we systematically assess association studies. If you're interested in this approach, here's a handbook to EBM+, which is open access. Evidential pluralism also provides an account of external validity. So this picture is like the previous one. We have association studies and mechanistic studies, but we also take source studies into account when we're looking at external validity. Here, causal claim may have been studied on another population altogether. You've studied your drug in rats or mice, for example, and studies on another source population can reinforce conclusions on the target population, as long as there's some evidence that the mechanisms of action in the source population and the target population are sufficiently similar. So again, this is another channel for mechanistic reasoning to play in establishing and assessing causal claims. So who uses EBM+? Well, the International Agency for Research on Cancer, when it assesses carcinogens, this can be viewed as a sort of model of good causal inquiry that conforms very well to the evidential pluralist picture. This is how they assess carcinogenicity. They have working groups that look at human studies to assess the extent of correlation between the potential carcinogen and cancer in humans. They have a working group that assesses mechanistic studies to assess whether specific mechanism hypotheses are plausible. And these mechanistic studies help to reinforce conclusions about carcinogenicity. And there's a working group assessing animal studies. And these animal studies can be potentially useful as long as there's a reasonable amount of evidence that the mechanisms in the species that have been tested are sufficiently similar to humans. So there is good practice that conforms to evidential pluralism. Some people have argued there's not enough good practice in that sense. And people have argued that perhaps EBM+ would have served us better than EBM during the pandemic. Evidence-based medicine famously let us down, particularly in the early days of the pandemic, when there were very few RCTs of the interventions that we were considering. Decisions had to be made about interventions, but when you focus on a very restricted evidence base, there's very little grounds for making those decisions. EBM+, people have argued, could have helped because we could have considered a wider evidence base. And just to reiterate, evidential pluralism accords with the weak thesis, not the strong thesis. So according to evidential pluralism, statistical techniques are useful, but they're not the whole story. So obviously, this alpha-1 channel, this is going to depend heavily on statistical techniques, trying to assess the extent of a correlation given the studies, association studies that have been performed. Statistical techniques are going to be useful in the assessment of mechanistic studies as well. But importantly, there are judgments to be made about the plausibility of a linking mechanism, judgments to be made about specific mechanism hypotheses. So according to evidential pluralism, causal inference can't be reduced to a simple statistical question. Careful judgments need to be made along the way, and causal inference is a combination of statistical inference and mechanistic inference. Okay, so let's get on to the replication crisis. So a question arises when a lack of replicability is actually a crisis. I don't think that a study fails to replicate an observed association. I don't think that leads to a crisis. That's quite a common occurrence. Studies often fail to replicate observed associations because the studies may be performed in slightly different ways on slightly different populations and so on. So I think that's just normal science and not of any concern in itself. The problem arises when these observed associations are taken to establish causal claims, because then if they don't replicate, then we have to retract the causal claims, the causal relationships that we've said are established, and that's a problem. Why is it a problem? Well, established propositions are used as evidence for further claims. So if you have to retract an established proposition, you have a lack of stability in the evidence base. You also need to reevaluate claims made on the basis of the propositions that have been revoked. Further than that, science can be thought of as making progress to the extent that it establishes its key propositions. And usually causal propositions are key to most empirical sciences. So if you have to revoke established causal relationships, that often gives rise to skepticism about the ability of a science to progress. And we've seen that a lot in the debates about the replication crisis, skepticism about research in psychology and so on. So I think a crisis arises when established causal relationships are overturned. A crisis doesn't necessarily arise when observed associations are found not to be replicable. But there's going to be a problem if you establish your causal relationships on the basis of studies that fail to replicate. And I think that's what we're seeing a lot of here is causal relationships have been taken to be established on the basis of studies that fail to replicate. So this problem is going to arise more regularly when you establish causation purely on the basis of association studies. It's going to arise more regularly if you appeal to few association studies to ground your causal claims. Obviously, if the association studies are of lower quality, lower down the evidence hierarchy, if your significance levels are too high or there's publication bias or other kinds of bias, these problems are going to lead to situations in which your established causal claims hinge on studies that fail to replicate. My concern as a bit of a bystander in this debate is that a lot of the action has centered around items 4 and 5, item 3 as well. And I would urge paying a bit more attention to item 1. And that's this problem of establishing causation purely on the basis of association studies. As I've noted, if evidential pluralism is correct, the strong thesis is false, and you need to establish causation by establishing mechanism and correlation. And you need to really scrutinize mechanistic studies alongside association studies. This leads to a broader evidence base, which is more likely to eliminate biases. And it's going to be less likely that an established causal claim hinges on a study that turns out not to be replicable. So broadening the evidence base is one way to tackle the replication crisis. Some people have argued that it's a better way to tackle the replication crisis than by ensuring successful replication. Why is this? Well, successful replication of a study can inspire false confidence in a causal claim because it may be you've replicated the observed correlation purely because you've replicated the biases of the original study that has observed the correlation. So some people have argued that there's a need for triangulation in order to avoid this, this false confidence in causation. And that means a need for a broader evidence base on which to base your causal claims. And evidential pluralism can be thought of as offering a kind of well-motivated route to triangulation. So I'm just going to close by talking about an example or two of when evidential pluralism can help because it can lead to caution when establishing causal claims. Evidential pluralism doesn't necessarily lead to a more cautious way of establishing causal claims because mechanistic evidence can reinforce the results of association studies and can inspire greater confidence in a causal claim in the right circumstances. But in certain troublesome circumstances, mechanistic evidence can undermine the evidence from association studies. And this can help us avoid the situation in which we establish causal claims and then later need to retract them. One example is the use of streptomycin to treat TB. So streptomycin was discovered in 1944. It was found to inhibit the TB bacteria in vitro. and it successfully treated TB in guinea pigs and was observed to help some human patients as well.
You have 5 minutes.
Okay. So in 1947 to 8, Bradford Hill carried out an RCT on streptomycin to treat TB. Treatment was given for 4 months, and then patients were observed for a further 2 months. And the RCT found a large correlation, so 51% of treated patients considerably improved, as opposed to 8% of patients in the control group. So you might think this is great evidence. However, Hill did not take causation to be established. Why not? Well, this was essentially for mechanistic reasons. There was evidence of streptomycin-resistant bacteria strains in several of the patients, and so it was plausible that the patients might deteriorate after the 6-month endpoint of the trial. So Hill advocated a much more cautious approach, and in the end, Hill was proved right because a subsequent follow-up on the patients confirmed his hypothesis. After 5 years, there was no significant improvement in the treatment group in comparison to the control group, and this was attributable to antibiotic resistance. Anyway, Hill carried out a further RCT, and this looked at a combination therapy, a combination of streptomycin and para-aminosalicylic acid. And this combination therapy largely avoided antibiotic resistance. So Hill's caution was well-founded, I think. Now, how would an EBM approach have treated that first trial? Well, it would have been viewed as providing strong evidence. It was an RCT. I think it was the first published medical RCT. So near the top of the evidence hierarchy, it observed a substantial correlation or effect size. And actually, that study was fully replicable. There isn't a problem about replicability there. Do the trial again, it's going to observe a similar kind of effect size. Hill's more cautious approach is validated by not EBM, but EBM plus or evidential pluralism, because Hill used kind of mechanistic reasoning, mechanistic evidence to undermine the results of his first RCT and to advocate more caution. So I think that's a good example of how evidential pluralism can lead to a more cautious approach in establishing causal claims, and that can help us avoid the need to retract causal claims that we'd previously taken to be established, and then we were been found to be flawed.
2 minutes.
Okay, I've got other examples, but I'm not going to go through them here. But John Norton, in his discussion of replication, has got 4 interesting examples: cold fusion, the discovery of Helicobacter pylori, Miller experiment, and intercessionary prayer. And I think they tell a similar story, actually, that mechanistic grounds can be used to urge more caution when establishing causal claims, and this can get round the problem of failed replication. So I just want to sum up. So it used to be a platitude that causation is not correlation, but I think that's no longer the case, unfortunately, because people think that we can get more out of statistical techniques, that the correlations are getting more sophisticated, the concepts of correlation are getting more sophisticated, and there are more accounts that conflate causality with some kind of correlation. So effect size is just identified with a particular kind of correlation, for example. This trend, I think, is pernicious because it leads to an oversimplified account of causal inquiry, and it's turning what is a part of normal science, which is the failure to replicate an observed association, into a crisis, because we're taking these observed associations to establish causation and then finding that we're having to go back on our tracks. So evidential pluralism provides, I think, a more comprehensive account of causal inquiry. And a broader evidence base is likely to be more robust in the face of these potential replication failures. Thank you very much.